Hey, fifth grade, how are you this week? This is our only video for the week of April 24th through the 20th through the 24th. And I wanted us to begin by looking at how we're going to solve our problems today. We're going to use our cube strategies with circling, underlining, boxing, evaluating what we know, eliminating what we don't need, and showing your work for sure. All right? Make sure you have your packet that I sent home from Success Center and that you're turned to page 75. So I'm going to circle that up real quick and we'll be working on page 75. Up at the top it will say exercise 45. Okay, the way we're going to work through the problems today is that I'm going to have you guys work through them a little bit at a time. So like we're going to talk about number one. You'll stop the video for a second, solve it, come back and see if you were thinking the right way on it. And we're going to do that all the way for 1, 2, 3, and 4 on this page. So let's look at number one first. I'll read it out loud. 3 fifth grade classes each have 22 students. Another fifth grade class has 20 students. Which equation can be used to find S, the total number of students in the 4 classes? We don't start solving anything or trying to guess anything till we start thinking through our problems. So let me pull up a pen and here we go. So I see that this is a number written as words, so I'm going to go ahead and circle it, but it's 3. And I'm going to go ahead and write a nice big 3 up here. 3 fifth grade classes. Each. By this time, you should know that each is a very important word. Each is an action word. It tells us to think, what are we going to be using? If each is up in the information part of the problem, not part of the question sentence, but up in the information, a lot of times it means that we're going to multiply. So let's just keep that in our head that that could be what's happening. So there are 3 fifth grade classes, each have 22 students. Okay, that's easy enough. All right, let me move my little circle over just a little bit. So there we go. Okay, now another fifth grade class has 20 students. So this class has a little bit less than the others, and it only has 20 students, and it says another. So that just means one. So we have 3 that have 22 and 1 fifth grade class, and I could even make another. I could just say, oh, that's a 1 right there. 1 fifth grade class has 20 students. Let's look and see what they're asking. Which equation, an equation has to have an equal sign, can be used to find S, the total, there's another word that we need to box up, the total number of students in the 4 classes. So it says I need to be using all 4 of the classes. Now, knowing what we've thought through here, pause the video, do a little bit of work on that. What is that going to look like? Turn the video back on and see if you were thinking the same way as I was. All right, did you work that problem out? I want to show you how I thought through it. Okay, I made my little classes as boxes here, and 3 of my classes have 22, just like this information here. 1 of my classes has 20, but I need to find the total that will be S down here. So if I look through, I need to figure out what operation am I going to use to find a total. And what is that operation that equals total? That's going to be an add. So when I looked over here at my answer choices, I didn't have something that said 22 plus 22 plus 22 plus 20. But if I have 3 22s, I can also think of that as 3 times 22. And each is a clue for multiplying over here also. So if I could find something that looks like this over here, I'll be good to go. Well, I have a 3 times 22. That works. But it says times 20. Am I going to do a times 20 with the 3 times 22? No. All I'd have to do is 3 times 22, and I'd need to add another 20 to that, wouldn't I? So that's not going to work. So I'm going to cross that out. Plus, it didn't have anywhere for a total. I know total means plus, so I'm going to have a problem that has a plus sign in it at least. Okay? So if I look at this one, 3 times 22, well, that sounds like 3 classes that each have 22 kids plus 20. That looks exactly like what I need. But let's look at the others real quick. This is 3 plus 22. Well, nowhere on here does it say that we have 3 more than 22 or 22 more than 3. And then it doesn't say anything about each of them being, 20 times each. So that's not going to help us. Now, we do have some adding signs here, but once again, nowhere did it say that we had 22 more than 3 or 3 more than 22. We do have our adding plus 22 there, but that's the only thing that matched on that part of the problem, okay? So that problem doesn't match exactly like what our picture shows, but this one does. Okay, I hope you understood the explanation for that. Now let's go on to number 2. Number 2 says, which equation could represent t equals the sum of 2 and the product of 3 and 12? Now, before we begin that, I want us to have just a tiny little talk over some vocabulary. So let me switch pages to show you that. All right, if you look at my page right here, I have some vocabulary that would be really important for you to know, okay? So we're going to go over some of these just to brush up a little bit on our vocabulary for math. Sum is our first one that we're going to look at here. Sum is the answer to an adding problem. So when you see sum, that means that you will be adding, okay? Now, product, okay? Product is the answer to a multiplying problem. So if you ever see the word product, it means that you would be multiplying. Quotient, really cool sounding word, right? Quotient is the answer to a dividing problem. So anytime you see quotient, you will divide, okay? Difference. Difference is the answer, difference is the answer to a subtraction problem. You see that? You'll be subtracting. Now, if we'll look at these over here, you should know by now that total means to add. That's a funny adding sign. Altogether means to add. And each, we talked about in our other problem, each is going to be a multiplying, all right? Or a divide. So it's kind of half and half. If the each is in the question sentence, you'll probably divide. Not always, but probably. Okay. If each is in the information part, not the question sentence, most of the time or many times, it'll mean that you'll multiply. So now that we have some of those in our head, let's come back and look at what our problem says right here on number 2. It says, which equation could best represent t? So we're looking for t being equal to something. T, I'm going to put the equal sign above it, equals the sum. We just talked about that. So somewhere in our problem, okay, I'm going to put a little thing out here. It's going to mean we have to add. All right, so it's going to be the sum of 2. Circle that 2 up. And the product, here's another one of our words we need to box up. And product was what? Multiply. And the product of 3 and 12. So that means product is the answer to a multiplying problem. So we want the product or the answer to 3 and 12, or 3 times 12. All right? So let's come through here. I want you to pause the video, choose your answer, and then come right back. Okay, did you find your answer? So if we just go step by step through here, we want the answer, okay, of 3 times 12, and then we need a plus 2. So do we have a 3 times 12 and a plus 2 in here? We do, right here. Now this one can't be it because we didn't have any 3 and 12 making a product or making a times answer. This one does. It has 3 times 12, but then it said times 2. This doesn't say each or product. It said sum. We needed the sum of 2, okay? And then we have this one right here that doesn't have a 3 times 12 at all in it, okay? So if you can take a problem step by step and do that, just go through there and pick through the vocabulary, you're good to go. So knowing your vocabulary is really essential. Now let's look at number 3. Number 3 is a weird one. So it says, what is the value of 6 plus a over 5 if a equals 15? Well, let's understand the problem first. Okay, so let's do our cube strategy. We have a problem that we have to solve. Here it is right here, and it is an adding problem, but inside that adding problem we have a fraction. That fraction has a letter in it, but luckily what's something really cool is that we already know what that letter equals. So basically what we have to do is rewrite this problem and replace anywhere where we see a letter A with the number 15. So pause the video, put that together, and see if you can figure out what the answer, the final answer to this problem is. So pause the video, do that now. All right, did you choose an answer? Let's look and see how you would solve this. Well, first of all, if you'll look, I've rewritten this problem and I've replaced the A with the number 15. Well, now I have an improper fraction, and I know that I can take an improper fraction if I divide the numerator by the denominator. I can find what that improper fraction equals. So I'm going to take my 15, which is my numerator, I'm going to divide it by my denominator, and look at what a simple dividing problem that is. 15 divided by 5. Well, it's 3. So if I come over here, I no longer have to deal with that weird looking fraction. All I have to do is say, oh, 15 over 5 is 3. So now I'm left with a very, very simple addition problem. 16 plus 3 is 19. There's my answer. All right. Now number 4 has some pictures here that we're going to be looking at in just a minute when we're trying to find our answer. But before we even start looking at that, we need to pick apart our problem. So let's do our cube strategy to our problem here. Number 4 says, Xavier, or yeah, Xavier, I think you say that, Xavier, has red blocks and blue blocks in a bin. A bin is just like a box, okay? He has twice as many red blocks as he has blue blocks, and blue box will be the letter B. Xavier has 111 total blocks. Which diagram below can be used to find how many blue blocks Xavier has? So let's come up here and let's do our cube strategy. So he has red blocks and blue blocks. That was a tongue twister. And here's the important stuff. He has twice as many. Twice means what? Twice means times 2. Twice means you do it 2 times, or times 2. Now, twice as many red blocks as he has blue blocks. And blue blocks are going to be B. Xavier has 111 total blocks. So if I come over here, I'm going to do a little bit of thinking, okay? But I know in the end, I have a keyword total. We talked about that on the other page. Whatever happens, there's going to be an add in here. So I know that right away. I know twice. So something about a times 2, or something's going to have to be done 2 times. I want you to pause the video, solve it, come back and see if your thinking was like my thinking. So right now, pause the video, solve the problem. All right, did you think it through? So let's talk it out now. I came over here and I did my thinking. So if you'll notice right over here, I said that if I have red, it's going to have to be 2 times a B because there are twice as many, and B is equal to blue. So a red is 2 times as much as a blue, and a blue is just the letter B. So if I came over here, and I have another picture for some people who like to see pictures. If blue is a B, then red would be 2 B's, but they're going to be mushed together, aren't they? So this is going to be, whoops, that's not what I meant to do. There we go. And so I'm going to put those together now. So they're mashed together. So this is a picture of a blue, and here is the picture of a red. It's 2 of the B's together. So let's come over here and look at our choices for our answers. A has 2 B's, just like we have over here. Then we have 1 B, just like I have over here. And it says, if you put all of those together, it should make 111. And look, my problem right here says that same thing. This looks like it could be our answer right here. So I'm going to circle it up, but let's make sure. Let's look at the other problems, okay? Right here, it says that this is 1B. Yay, we have that. But then it has 2B saying that it's this whole entire thing. Well, that's not what 2B should be, okay? Or 2 times B. If you write a number before a letter, you remember, we can assume that it's a multiplication problem there, okay? It's not what this was. That didn't show a picture of this. And then we have a 1B. But then it shows 2B being the exact same size. Well, that can't be it because 2B has to be twice as big. And then it says the 111 is that one little bitty tiny block there. No, 111 is all of them together. That can't be it. And then this one shows 2B is 2 big blocks and then they all add up to 111. No, that can't be it. That didn't look anything like what we had written over here. Okay, and I just wanted to go ahead and remind you that B times 2 could also be written as 2B, right? And so A is our final answer there. Well, I hope you've learned a little bit today. We worked on page 75 for this week. I've noticed that I have just a few people going to Study Island. I would like to see a lot more people going on to Study Island, and I hope that you're enjoying the 1 time a week video where we're working through your book and helping to improve some of your math skills, okay? So until next week, I hope that you have a great rest of your week, and I do hope that you will spend quite a bit of time on Study Island this week, especially since we have some people who have skipped out on that for a few weeks now. Anyway, I hope you have a great week, and I'll talk to you later, and bye.